Welcome back, my dear friends and dear students. A very good morning, good afternoon, good evening to all of you wherever you are. And as you know, this is the DADM2, which is data analysis and decision making 2 course under the NPTEL MOOC series. And this total course duration is for 30 hours, which is for 60 lectures spread over 12 weeks. And each week we have 5 lectures, each lecture being for half an hour, and we are in the 5th week. And as you can see from the slide, it is the 25th lecture, which is in the last lecture for the 5th week. And my name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. So, we were discussing the AHP ranking of buying a car, and when you are taking a decision, if you remember that we had considered first the subjective criteria, the style, fuel economy, cost and so on and so forth, and then you first compare amongst themselves, make a priority vector based on the priority matrix. Then you take each and every criteria for all the alternatives combined together one at a time. Then also you have separate priority vectors, combine these priority vectors for both the levels and both the hierarchy, multiply to get the score. Now, if the cost factor comes, as the fuel economy was there, kilometers per liter, that can also be normalized using the same concept of normalization, which I am repeating it time and again. That can also be considered, and that can be added on to find out the final ranking. Now, if the cost structure comes, I said that adding or subtracting one of the criterias or one of the, not of the alternatives, but the criterias may change the relative ranking of the criterias, like I bringing a 4th one in this case, or say for example, adding say for example, deleting of any arbitrary 3rd one, provided there are more than 2, the ranking may change, relative ranking. So, here also you consider the cost structure, and there can be different flavors of the problem, remember that, and you can basically find out the relative scores. So, continuing with this, once you have the combined scores, so Escort is the winner with the highest benefit to cost ratio, hence it is in the first position, combine all the scores. Second position will go to I-20, third to Alto, while the 4th position goes to Civic. So, obviously, at this position, depending on the criterias which I have already mentioned and the cost structure, you have this. So, the problem concept is very simple. You have to find out the priority vector, priority matrix, priority vectors, rank them, combine one level at a time, and also told that they can be primary level, tertiary level, then below the tertiary level, one level, 2 levels below the tertiary level, and you can go on, such that you add up the scores as you go up and keep multiplying and adding them, such that you give a final scores to rank them. Now, obviously, there are some pros and cons for AHP. So, it allows multi-criteria decision making, which is a very good point. So, multi-criteria with different types of subjective, objective concepts can be rationalized, and obviously, you have seen that consistency ratio, consistency values or the scores will give you how consistency concept can be utilized in trying to analyze how rational your decisions are. So, that can be utilized. So, AHP is applicable where it is difficult to formulate criteria evaluation, that is trying to basically combine qualitative and quantitative is much more rational using AHP. If rationality definitely would be considered, we can add them accordingly. It is applicable for group decisions. So, when there are more than one decision maker and the decision has different type of alternatives, different type of criterias. Like if you remember a very nice example, though not solved in details, because it was very simple problem, Ram and Shyam making a decision to go to the MBA schools, and then their father come. So, at each level there are many decision makers, and then you combine. Say for example, you are trying to analyze the problem where you have, say for example, I have mentioned it very briefly. So, say for example, candidate has applied for the HR general manager or HR senior manager, and on the other side of the table the MD, the chairman, the vice presidents, like say for example 5-6 persons are sitting and they want to analyze how the good or bad the candidate is. So, you will try to basically analyze the candidate's academic credential, what type of work experience he has, and what is his psychological profile, and what is his demand of salary, and all these things would be considered, but all the people who are trying to analyze the candidate will have different criterias, different levels of scores for the same set of criterias. So, combining them would give you a much more better perspective. Now, when you are combining, for the case of Ram and Shyam, their parents were giving equal weightages to their sons Ram and Shyam. It may be possible that the chairman and the MD has a higher say, hence technically the scores which you will assign for the overall ranking coming from the point of view of the chairman and the MD would be higher, while the general manager and the vice presidents who are trying to analyze the candidate, their score would be lower. So, which would be a much more rational decision process when you combine all the alternatives, all the criteria and take subjectivity into consideration. What are the disadvantages? So, there are hidden assumptions about consistency, and consistency trying to find out level consistency to be equal for all the decisions is difficult, because it becomes very difficult to for me, maybe it is very difficult when I am trying to analyze the decisions on a one-to-one basis. That means, I is to j and forgetting about all other criteria or all other alternatives which are there. So, I only consider an I and j, but when I come to j and k, I only consider on j and k. So, trying to combine, and then when I come back to I and k, then j is removed. So, trying to combine I j, j k and I k, I j k are, say for example, the decisions or the alternatives whatever it is or the criterias, and then trying to basically combine them and find a relative ranking between I, j, k may not give us a very good consistency ratio. So, this has to be thought about. Repeating evaluations is cumbersome, because repeating the same thing time and again may not give us the same relative scores which we actually want to have. So, if you remember the principal diagonal is 1, there is no problem, but trying to basically combine for civic and I-20 on different fronts, the differences of the scores may be very vague if you keep repeating that. So, hence the actual scoring system which should be between the cars or between the criteria may not come out when any person is analyzing. Or it may be possible that, say for example, when buying a car, the first person analyzes and gives the score, that the second person, when he or she wants to give his or her score, he or she may be influenced by the decision of person 1. So, those influences we consider are not there, but it may be possible those decisions are there. Say for example, in the other example, when trying to find out how would you recruit a senior manager for the HR. So, the chairman may have a higher say, and his or her saying may have an influence on the vice president, on the general manager who is also trying to analyze, and they may be influenced. It is difficult to use when the number of criteria alternatives is high, it is more than 7, because trying to compare 7 C2 combinations, because taking 2 combinations from 7 set becomes very difficult and very confusing when you keep repeating this comparison. It is definitely difficult to add a new criteria and an alternative, because the relative ranking of the alternatives and criteria would change. Absolutely true. This is one of the most difficult points for AHP, which does not give it a positive light. Obviously, it is on the negative side, but still AHP is used quite heavily. And it is also difficult to take out an existing criterion or alternative, since the best alternative might differ when you compare them against the existing alternatives when one of them has already been taken out. So, the relative ranking would suddenly change, whether you add that or you take it out. As I mentioned, if you have, say for example, 7 different alternatives, I am considering in a very arbitrary sense, and if you take out the one of them, then the remaining 6 ranking may change, relative ranking, or if you basically have 7 1 and you add the 8th one, then also the relative ranking may change, because the scoring pattern which you are doing for even the same person would obviously change quite drastically. Now, I will just go through some brief, very simple mathematics. This is just for the information. So, this I thought I should have covered in the initial part, but when I was making the slides, I thought that best for AHP is to discuss the concept, go directly in the problem, and then come back to the simple concept of consistency, which I had been repeating time and again today also, that means in the 25th lecture and also in the 24th lecture. Consistency implies coherency in the judgment process. So, this is coherent concepts or coherency of logic or logical sequences of steps are there when you make a decision, whoever it is making a decision, buying a car, choosing a house, or trying to basically recruit any person in your company. And basically the coherency should be there in the judgment process, as I just mentioned, for the decision maker, but given the problem in human judgment, the property of consistency may not always hold true. So, that may change. So, that is why we do the consistency check through the ratios. Few of the important properties for consistency is ours. Now, for consistency we would always have the, if you remember the I, J, K's, this suffix which were there, and the numbering was depending on the number of criteria, number of alternatives. So, if you have I, J, K running from 1 to n, and if you find out the multiplication. So, if you remember, I multiplied the matrix with the vectors to give the overall ranking. So, if you multiply this A I J cell with the A J K cell, the values gives us the total number of such scores, addition of the scores. So, what you are doing is you are adding up the values I j k, A j k for all values of j. So, that will give you one value which will be in the vector of the final score, if you remember we have done that. So, those doing that number of times obviously will give you a different levels of consistency. For a 2 by 2 matrix, it is always consistent. We would not go into the proofs, but I will state it. So, consistency implies that all rows and columns are linearly independent. So, it is something to do with matrix, a linear set of equations. If you remember the Gauss-Jordan method of elimination, we are considering that there are n number of equations and n number of variables, and each of them are independent, all equations are independent of each other, hence you will get unique solutions. So, if you basically have the matrix concept, so here all the rows or all the columns are independent and none of them can be expressed as a linear combination of the other, hence the concept of rank will come out of the matrix as that the rank would be n depending on the number of rows or number of columns which you have. Now, the matrix is consistent. So, consider it is of the form that you have the weights given as W1, W2, W3. So, these are the weights. For the first one is W1, second one is W2, similarly for the last one is Wn. And the values which you have for the priority matrix, obviously as usual the principal diagonal is 1, and the of the diagonal element which you have, these are not symmetric. So, A21 is not equal to A12, because if A12 is 9, A21 will be 1 by 9, or if A21 is 7, A12 will be 1 by 7. Similarly, if I consider AN to A2n, again they are not symmetric, because the scoring pattern which you are doing for the criteria and the alternatives are such that you follow the same the scheme of scores of 1, 3, 5, 7, 9, and if there is ambiguity you bring the even numbers. So, in this case it is an asymmetric matrix, the principal diagonal being 1. So, this is the priority vector. So, if I find out the weights, so weights would basically be the ratio of the sum of all the corresponding rows of the columns, and if I have them, the correspondingly the weights W1 or W2 or W3 will be found out accordingly, and we can find it. So, this is just a end result. I am not going to go into the actual mathematical derivation and the use of that, but remember one thing, consistency property is important for AHP. Point 1, the ranking system would change if you add or delete a particular criteria or alternative, that is also important. Trying to find out the priority matrix, you have to have the level of consistency judgment following up in the rational front such that consistency ratios or consistency concepts are not violated in the final decision. Given the consistency matrix, you will try to find out the consistency vector, the priority matrix, you will find out the priority vectors and go from the lowest bottom level from the tertiary to the primary and so on and so forth to give the cumulative scores, where you find out the sum of the multiplicative factors of the scores. And another thing which I have repeated time and again. So, remember that the utility function which you follow on normalizing, whether through the rows or the columns, such that the sum is equal to 1 after normalization. The normalization concept of whether it is quadratic or exponential or power function or logarithmic function, whatever you are utilizing, would be used consistently for the same person for all the alternatives and decisions, and try to use the same normalization concept of the utility function for all the different persons when you are trying to combine the decision makers, like decision maker 1 or 2 or 3 or 4, when trying to arrive as a collective decision, like say for example, for the car, or say for example, trying to recruit a person, the example which I had given. So, with this I will end this AHP part and then start of a new concept of the ELECTRE process. So, this technically I thought as we were going in the flow, it would have ended in the 25th lecture and end of that, but I have finished a little bit ahead of time. So, whatever time is left for this 25th lecture, which is the last lecture for the 5th week, I will consider a new important topic to be added. So, just bear with me, I will open the slides and discuss that accordingly. So, this is the AHP part, and just one thing. So, finally, to wrap it up for AHP. So, then once we find out, sorry for that, I just missed this slide. So, when we find out the actual A matrix, so they would be normalized. So, and finding the ratios. So, once you find out the ratios, hence the matrix A, which is the normalized concept, you multiply the weights, it will be equal to n into W, and if and only if A is consistent, and in this case if they are inconsistent, you can find it out, but for the consistent scores you will use the average. If you remember in the first example, when we are doing the consistency ratio, we found out the averages and proceeded accordingly. So, so these are just for interest, you can pick up the Satty's book, the references which are already given when I started the class. So, you can check that and find out the actual mathematical formulation of consistency, how it can be utilized. Here in this course, if you remember, we are just discussing the application of different type of MCTM processes. So, with this I will end, I will again repeating, I will end AHP and then I will try to start. So, we are continuing the 25th lecture. So, just for when if at all I upload the slides, so I thought there should not be any confusion. Okay. So, we are going to start a new method which is known as ELECTRE, which is elimination and choice translation reality. Now, I will try to finish all these standalone topics in such a way, so there is continuity without this break which happened in this fag end of the 25th lecture. Obviously, there is no confusion, but to make a smooth flow, it will be much more easier for you all to understand and easy for me to continue without any break in the flow. So, what does ELECTRE mean? So, ELECTRE is basically the word is a French word which basically means elimination and choice translation reality. So, you are doing the concept in such a way that you have a set of criteria and decision, and you try to find out the best possible decision, which is a theoretical concept, such that you will try to find out the positive distance of liking from that the so called theoretical set or theoretical value for all the decision making decision alternatives which are there, and also try to find out the negative weights, that means the negative distance from that so called theoretical value for all the decisions which you are forced to take due to some circumstances. If you remember, I did mention one of the example that you are a bank and you are forced to, or due to government regulations you are told to open it in the rural district. So, if you consider that profit motive is the important factor, obviously that is not the best choice, but still you have to do that. So, how do you make a decisions accordingly? So, you will consider some distant matrix coming out such that you will divide the overall decisions into two sets. Number 1 is a positive set which gives us positive values, and a number 2 is the negative set which gives us negative values, and then try to compare and combine this positive set and the negative set and try to basically take a collective decision. Now, the point of positive set and negative set is in this way. Set means a set of scores which you are giving. Now, the point of positive and negative set is in this way. Say for example, there are two alternatives I and j. Now, we will consider, as we have done in the HP, that you give a score of 9:19, 5:15. So, the point of 9 or 5 or 7 or 4, whatever it is, you are giving to the case of the decision of the alternative which is positive to you, and you give a inverse of the score to a one which is definitely not positive to you, but you are being forced to take the decision due to some circumstances. In the similar way, we exactly do this. We basically compare two decisions, two alternatives I and j, and if I is better, we give a positive score, a positive point to I, and when if we are forced to take j, we also give a score, but the point is that you try to rationalize the score in the normalized scale, that I is to j and j is to I, if the points are equal, which means that I am equally disposed whether I take decision I or decision j, and if I am not equally disposed between I and j, say for example, I like I more than j or I like j more than I, in that case the preponderance of the scores between I and j and I, if I like I, and if I like j more than I, then the preponderance of the score of j to I and I to j would be such that the points of j would be higher. This would be coming up correspondingly using some very simple concept of liking set and disliking set. Here remember, in the initial case we will consider the liking and the disliking set to be such, to be made in such a way that the distant matrix are of equal proportions, in the sense if I like something, my propensity of distance would be of same magnitude as to the level when I dislike something, which may not be true, because in the actual sense, if you remember, I have discussed the concept of asymmetric loss functions, where I am assigning a higher score or a lower score, or a higher loss or a lower loss depending on whether my estimation is high or low. If you remember, I have considered three very simple examples. One was basically for building the dam from the civil engineering concept, one was basically from the electrical engineering, where you have a set of a machine is there and you have vacuum circuit breakers to understand that when you should basically do the general maintenance of that very costly machine. And another example was that when you are trying to float in a product in the market, from the market perspective, the warranty life, it is high or low, would basically help you to gain the market in the initial case, but you lose the market as your product fails earlier, or in the second case that you are not able to win the market in the initial case, but you will slowly gain the market as your products being popular, considering the warranty time is actually different with respect to the competitors. So, these three examples gave us the concept that whether overestimation is important for the case when building the dam, underestimation is important for the case of the electrical circuit, and where case overestimation or underestimation can whatever is important for the marketing example. So, this concept initially we would not use in the ELECTRE, and but we will try to bring that using the distance concept. In course of time, 6 different I have not finished the first bullet point. So, this is the elimination and choice translation reality, which is in English. It was developed by a Frenchman, by Roy in 1990s, when trying to basically analyze different huge projects where decisions were both subjective and objective, to arrive at a rational decision in trying to rank projects where different criteria, different alternatives were utilized. It is one of the MCDM tools based on the concept of outranking method. That means how good or bad your ranking system is, how you are able to outrank other decisions or other alternatives. In course of time, 6 different variants of ELECTRE came into the picture. They are ELECTRE 1, 2, 3, 4, TRI and IS methodology, and they have been developed where each has some unique properties, hence variations when compared to each other would be there, but we will only consider the simple concept of ELECTRE, how it is utilized. A good text related to comparison of these 6 different ELECTRE method can be found by was basically the inventor Roy in 1990 and one paper in 1996, and by Rogers the paper was out in 2000. For our understanding, we concentrate on the basic concepts of ELECTRE 1 process only in a very simplistic sense, but as I said, I will add the concept of outranking in asymmetric sense also, like whether I like or dislike, the weights would be different depending on the level of loss function or the asymmetricity which you want to bring into the picture. And afterwards, we will give comparison of each of the 6 different variants for the appreciation of the readers or appreciation of the students who are doing this course. But I will main concentrate on the ELECTRE method with outranking concept being equally disposed for whether you like or not like, and then being unequally disposed using the asymmetric concept of loss. The concept wise, we will bring it very simply. The first question which invariably comes into one mind is, what do we understand by the concept of outranking? So, what does outranking mean? Does it mean a relative score? Does it give us an absolute score? What does it mean? Stated very simply, the method of outranking is the idea in which one compares one decision or alternatives against all others and ranks them based on some set principle. And as you do that, you are trying to basically find out the relative score where the decision and the alternative stands with respect to all the other sets of decisions and alternatives. In doing so, one assures that at the end of the pairwise ranking, here also it is a pairwise ranking. So, if there are n such alternative decisions, you take the jth one and compare the j to 1, j to 2, j to 3, so on and so forth, and then you go to compare j to j minus 1, j to j plus 1 and go till j to n and put j alternative decision in the right perspective where it stands. So, let me continue reading it. In doing so, one assures that at the end of the pairwise ranking process, we have a unique ranking system amongst all the decisions or the alternatives, such that we are able to take the decision correspondingly. Now, nomenclature would be important. So, I will go a little bit slow. Thus, intuitively consider you have the alternatives A given as A1 to AN. So, each alternative will have criterias. So, it can be C1 to Cm for A1, then again C1 to Cm for A2 and so on and so forth. Now, the number of M which you will have for A1, A2, A3 need not be same. So, if they are not same, so obviously we will consider some of the cells to be blank or replace them accordingly in order to have a consistency concept of ranking. This word of consistency I am using not from the AHP point of view, just from the English language point of view. So, where the number of alternatives is given as n, such that for each alternative there would be not m, but we are considering L number of criterias. So, when we are comparing AI1 to AI2, AI1 means the suffix is I1 is basically the I1 is one element of n and I2 is also an element of n. When I am considering alternatives 1 to 2 or 1 to 3 or 1 to 4, like I said I1 to I2, then I will consider each and every criteria to be considered, such that I am able to compare using criteria 1, I am able to compare AI1 and AI2, then considering criteria 2 and again I am able to compare AI1 and AI2 and continue doing that, such that I assign scores at each level of the distance and then do the collective combination of the scores. So, it says that these 1 to L are the set of criteria and one accomplishes his or her ranking based on the collective of the cumulative effect of all these L criteria which I just mentioned when comparing two different alternatives one at a time, and or say for example, considering the other things accordingly. At the end of the comparison process, we end up with the best choice set, where we say that A1 or A2 or A3 are ranked in such a way based on the criteria, we can rank them accordingly. So, with this I will end the last lecture of the 5th week and continue the discussion of ELECTRE in more details and solve a problem in the same concept, solve a problem and then come to the actual mathematical algorithm of decision process, how you make that. So, have a nice day and thank you very much for your attention.